Hey guys, it is Mr. Dave with the RayKitty Creation Workshop, and you are joining us for the RayKitty Science Project. Thanks for tuning in. We've got some fun stuff here today, some really cool science, some very accessible science. And by that I mean it's terms and concepts that a lot of students have heard, and it is very easy to do at home, very inexpensive. You can probably do everything that we're doing here today for maybe $7, okay? The only part that I do have that may be a little different the way you do it is I have these right here. These are plant lights. I'm doing that because we are here in the studio and we don't have that natural light. But you can use plant lights, you can go outside. Now I know that's scary, but you can go outside if you don't have access to plant lights. You can also use, if you're as old as I am, you may remember incandescent lamps. Yes, the ones that you put in your easy bake oven. Yeah, that's because they generate that heat and the light that would be needed. A UV lamp will also work for this. There's a lot of different kinds you can use. One of the things you can do is experiment with them. Most of the lights that you've got in your house by now are LED or possibly fluorescent. Some of them may work, some of them may not. But you're always safe to go outside with this one because that will work, okay? Like I say, I have these plant lights, and so that's the only part that's a little different, but this is not a necessity. This is just to kind of make it happen a little more rapid here in the studio, okay? So what we're gonna be talking about, or let me get a couple more things that you will wanna follow along with. We have our baking soda, okay, or sodium bicarbonate, right? That's very important. So we have our baking soda. We have dish soap, okay? This is just in a little ketchup bottle, but yeah, this is just regular old dish soap. Any dish soap will work. We have these syringes, okay? Now this one is something that you can purchase. They sometimes will have them at the dollar store. You don't want the needle on there, but they'll have them either at the dollar store. They always have them at a pharmacy. Very inexpensive. If you have multiple students doing these ones, you could get a couple students to use them and kind of compare and contrast, but this is just a syringe. This particular one is a 20 milliliter. You can go down to a 10 milliliter, which is about half this size. Any smaller than that, you have a hard time doing the project. So a 10 or 20 milliliter syringe. I have a little bitty hole punch, okay? You can have a hole punch like this one that does circles. You can do little heart hole punches, whatever you've got. You can also just use some scissors, but I like this one because we're actually going to be punching holes in spinach, okay? Now, I'm from New Mexico. I was raised all my life saying spinach, like it ends with a D-G-E, but it's actually spinach. I know, I read it on the bag. So we will be using spinach and we will be punching holes in it, kind of like an Eric Carle book. So if you're that very hungry caterpillar, you can use that hole punch to make that. The rest is just spoons and cups and water and things like that that you've already got. So what we're going to be talking about is photosynthesis, okay? Now photosynthesis is how plants will turn light energy into an energy that starts in our kind of food cycle, okay? Now there's a lot of different steps and a lot of different chemical reactions to photosynthesis. We're going to talk mainly about the plant producing oxygen, okay? Now when it is producing oxygen, I'm going to kind of give you an idea here. We've got this little like the circle of life, yeah, kind of thing going on here. And we have this sun, okay? The sun is going to be what is giving us the light. Yeah, it's the sun. You can tell it's the sun because it has sunglasses on. I don't know why the sun is always wearing sunglasses. Yeah, I don't know. But we've got that little sun there. And that is going to, I am no Morgan. If you've been a long-term New Mexican, you'll remember our wonderful weatherman that would draw these amazing suns. But we've got our little circle of life, and we've got a plant up here, okay? And then you've got something that will eat the plant and breathe the air. I don't know why that looks like something from Dig Dug, but you've got that little thing that eats the plant, breathe the air. Then you have something bigger that eats that and also breathes the air and has sharp, shiny teeth. But then you've got these guys over here. And Those are the little worms and bacteria that will go through here. If you just saw one of our last episodes, we did show some of that bacteria that helps in that breaking down. That breaks down, puts it back in the soil. So you'll have this idea here, but we're going to start with an easy and fun way to explain this concept to some of the younger students. And what we'll need for this one here, I have some wires, okay, some little alligator clip wires, and I have a solar cell, okay. Now, you can, as I said, you could probably do everything on this table for a couple bucks. You can actually go to the Dollar Tree or dollar store, and they have the little like yard lights, okay. They have those little yard lights there. If you take that yard light apart, you will have everything that you need to do this experiment, okay. Now that yard light will also store energy. Okay, so if you are using the yard light, you'll want to eliminate the battery from the system and just have the solar panel, the wires, and the light. Now I'm using a little bitty LED here, and this little LED, I'll show it up against this here so you guys can see it. If you do want to do like an LED project, these LEDs are very inexpensive, but like I say, you can get everything you need right out of that Dollar Tree lamp. Okay, so we're going to show you a little circuit that will kind of represent that same little circle that we've got going on when our plants produce oxygen. Now, this solar cell does not, this is kind of a tricky statement, so does not store electricity, okay? Kind of a tricky statement because it kind of does, okay? Now, the reason I say that is because this solar cell has all kinds of electrons in there, right? If you've seen one of our episodes before where we're talking about electricity and the movement of electrons, electricity is when electrons are moving. This already has the electrons, but so do I, right? We all have, all of these electrons in there. They're part of our atoms and things that we have in our universe, okay? So what I'm going to do is I am going to clip this onto here. I have little like solder points on the back. I took the wires off of this because it's just easier to clip it right on there than try to go on the little wires. And I'm going to put the black one onto the negative and the red one onto the positive. Okay? So if you've got that little plant light, it'll already have that loop in there for you. As I said, you'll just have to take out the battery portion and just wire it directly, okay? So that's a very inexpensive, very easy way to do this one. Now I'm going to take my little LED, okay? That's this guy here. I'm gonna lean this up against my belly so you guys have a little better view against the backdrop here. And I am going to hook my little leads here onto my LED, okay? Now an LED can actually function as a solar panel, and a solar panel will actually produce light. The deal with solar panels producing light is that they produce it kind of outside of the visible spectrum. So we can talk about that in another episode, and that is a fun concept. But as you can see here, I've hooked these onto these leads. Now, my negative is onto the little short leg. My positive is onto the longer leg. LEDs are polarity sensitive. We don't have to worry about that. If you get it wrong, switch it around. No big deal. Okay? So what I have here, and I'm going to hold it up, is this little circuit right here. Now, before we really get that light going, I'm going to kind of show you on our little whiteboard here how that's working. Okay? Now, remember how I said with photosynthesis, our plants are generating oxygen, right? In addition to becoming food, energy, and all of those kind of things. Now, the same idea, it's a little bit different, but it really is the same principle. When we have, let's imagine that this is our little solar panel, okay? Imagination. So that's our little solar panel here, okay? And our solar panel, we have our little clippies on there on our positive and our negative. Okay, so this is our positive, this is our negative. Now over here we have the sun. This is the sun again. Again, like I said, that I don't have the mad skills of Howard Morgan, but you know, love there because that's awesome. That is New Mexico true as you can get. So we have this sun here, and we have our solar panel. So we're gonna, our little clippies are now coming over to our LED. Okay. So our LED is down here. Now, we have the electricity, we have those electrons, but nothing is getting them moving. Remember, electricity is the movement of those electrons. So what happens is our little sun here hits the solar panel, okay? And the light there, let me see it, make sure I do this. I'm going to turn this around just so I make sure I can write my letters right. There you go. That way I don't do my P backwards. So the light, the photons in the light, okay, will hit this little solar panel. Now there's a lot of science as they drop and you know, transfer and all those kind of things, but a photon goes in, and when it does, it ends up kicking out, I had to turn around again, there you go, it ends up kicking out an electron, okay? So the photon goes in and it kicks out an electron. That starts that chain of electricity moving. The photons go in, they drop energy and turn into these, or well, kick out all of these little electrons, okay? Now there's a lot of deep science there. Like I said, we can kind of get into that in another episode, but the idea is that the light goes in and this little cell kicks out the energy, okay? So we have our photons in and our electrons out. So let's see that kind of in action here. I've got my little light here. I'll have my light on this side. I'm going to leave the light on the black part, and I'm going to put my little solar cell underneath my plant lights. Now, as you can see, this little light isn't lit up yet, but when we expose our solar cell to the lights, okay, we have the photons going in, and on our little LED here, okay, this is really like a crazy Rube Goldberg machine because we have light generating electricity, which is generating light, which is not powerful enough to generate any more electricity. So we have our solar panel here generating light, right, which is kind of a waste. But we can see that concept happening as this is collecting the electrons. Now watch as I get closer to and further away, because that'll be very important. If you watch this little LED here, as I'm getting closer to the light, our light source gets brighter, our little LED gets brighter, and as I go away, it gets dimmer, okay? And that's because it's collecting less of those electrons, okay? I mean, less of those photons, so it's not pushing through as many electrons. So this little circuit here is the same idea as photosynthesis. It's not exactly the same, but it is converting one type of energy, our light energy, into electricity, into another type of energy. Now, I'll show you over here. I'm going to turn these guys off for a second. And we'll show you the photosynthesis, and then we can kind of draw in how those two work together. So I am going to erase my board here. Remember this. There you go. Take a little mental picture of that, because in a second we're going to show you the photosynthesis that works the same way. So what I have here is you don't need fancy beakers for these. You can use clear plastic cups. You will want clear plastic cups so you can kind of see it from the side. But what we have is this is normal water, okay? Now, normal water is fine, but our plants convert CO2 into oxygen. So in order for that to happen, remember how I said this is sodium bicarbonate? So in order for that to happen, we need to have a carbon solution. Okay. Now you may have heard of like carbon footprint and all of those kind of things and reduce your carbon output. Well, when the atmosphere builds up with too much carbon and the plants can't transfer it, that's when we kind of start getting out of balance. Everything in the universe is looking for balance. Okay. So what I've got here is I have some of this sodium bicarbonate. Now if you look on the spoon here, I have not a whole lot. Okay. So I put about 1/8 of this spoon on there. Now, if you want to use an actual measurement, it is about 1/8 of a teaspoon. But really, it's just like, there we go. It's just like not a whole lot on that spoon. I didn't have it at quite enough of an angle there. So you can see that we've got some of that sodium bicarbonate on there. We're going to put that into the water. Okay. I may not even use all of that. I'm going to have a little bit left. So maybe just a tad less than I had there. Okay, so we have our sodium bicarbonate in the water. We're going to stir it around. Now what's happening here is it still isn't quite breaking down enough. And that's why we want to use our emulsifier. If you remember one of our other ones when we were talking about our polarized and non-polarized particles, our emulsifier, which is dish soap, we're going to put in there to help break that down. Now, when we do this, this is important. You need a teensy-weensy drop. Boop. There you go. Okay? See that there? That is all we need for about half a cup of water. Very little dish soap. Okay? Now that dish soap is going to help, as I said, kind of transfer that carbon into the water and kind of spread it about in the water there. And so our carbon, when you're stirring it also, make sure you're not getting it all bubbly. Okay? It's better not to have it all bubbly. So we made our solution first. This is our carbon solution. Okay? I've got that stirred up. I'm going to leave that spoon in there. We're going to scooch this to the side so we can do this next step. Okay? Now, this next step is the fun one. If you are doing with younger students, you'll have an easy time. They'll enjoy this one here. I've been doing this one in classes all week, and like high school, everybody just goes crazy with putting the little holes in here. So these are spinach leaves. Okay, if you have fresh spinach, like you have a plant or something like that, it'll work even better. But this is just from the store spinach leaves. Now, what I'm going to do is I am going to punch little holes in my leaf. Now, we don't need the leaf, we need the little punches that come out. Now, as you can see, we've got this kind of hungry caterpillar thing going on here already with our leaf. But I'm going to continue on. I'm going to want maybe 10 or more of these little punches. Now, you want to try and avoid the veins in the leaf. Okay, so kind of try and stay away from the veins in the leaf, but you can see as I'm punching those little holes, my little bitty spinach pieces are falling onto my, well, it's not really a tray, but onto my little whiteboard there, but I'm going to call it a tray because I'm using it as a tray. And I'm going to punch these little holes, give us our little hungry caterpillar there going on, and we'll get quite a few of these in here. Like I said, 10, maybe 12 of those little punches. The number really is not super important. You just want to have enough to kind of be able to measure that. Okay, so I've got some in this leaf. I'm going to do one more leaf real quick. Try and find the greenest, happiest leaves that you can, and they will work a little better. As I said, if you've got fresh spinach, then use that. It will work even better, but I don't like spinach. So I don't have any spinach plants at my house because it's yucky. Now, if you are doing this and you want to kind of experiment and take this a little bit further, you can also experiment with different plants. Okay? A lot of plants will give the same result. Some of them a little faster, some of them a little slower, but spinach is very easy to access and very easy to kind of get, and everyone, kind of knows spinach. So what I'm going to do is I'm going to collect my little dots that I have here. I've pulled the plunger from my syringe. That was that pop sound. And I'm going to put all my little dots into my syringe. Okay. Now, when you're doing this, be careful not to mash them up. Try and take the best care of those little guys as you can, because the happier they are, the more oxygen they will produce. And as I said, photosynthesis is the production of oxygen as well as turning these into just straight food energy, right? We're going to be looking at the respiration, or them actually breathing out oxygen. This is really like a great way for a student to see those plants actually in action. Now, what's going to happen is we are going to take all these little guys that are in my syringe here. Again, I'm going to lean this up just so I have a nice background. I should have wore a white shirt today, but we can see those guys in there. I am going to push the plunger back in. Again, being careful not to damage those leaves too much, but I'm going to push the plunger in, and I'm going to try and just slide them in as far as I can toward that end, because we don't want a lot of air in there. Okay, so we have our little spinach leaves. We are going to, with our carbon solution that we made earlier, we're going to have the carbon solution. I'm going to pour this about 3 centimeters deep. So you're not worried about the amount you have. It's just you don't want it too deep because we need that light to penetrate. Okay, so I'm going to now collect in my little spinach syringe our little bitty punches, okay? So I'm going to collect those punches. I'm going to collect some of that carbon solution. I went up to about 10 milliliters on this one, and I don't want a bunch of air in there. So I am going to very gently push the air out of there, okay? Now, some of my little spinach leaves got into the nozzle of the syringe. That's okay. You don't want a bunch of air because we want to create a vacuum. Now, if you notice, our spinach leaves are floating at the top there. You can see them floating right at the top of our material, okay? So what we want to do is they're floating because they already have some of that air in there. We need to get the air out, and we're going to do that by generating or creating a vacuum. So I'm going to do this to where you guys can kind of see here. I'm going to pull the plunger and create a vacuum, okay? In that vacuum, it's now sucking all of the air out of our leaves. You can actually see those bubbles forming, okay? Now, our leaves are still floating at the top, so we know they still have air in there because they're still lighter than the water. So I'm holding this for about 10, 15 seconds, okay? And then I am going to put my thumb on the top so it doesn't end up shooting in my eye. And then I'm going to release the plunger, okay? Now, when I did that, we have that little vacuum with those leaves. I'm going to kind of wiggle it around. Now, this part here, you'll probably do 2 or 3 times. So I am going to now do it again. And what's happening is we're creating this vacuum that is sucking the air out of the leaves, okay? Now, we want to do this because we want to see the oxygen that these guys will produce. So I'm pulling this plunger down. I'm going to hold it. I'm going to swirl that around a little bit, see if my guys are sinking yet. Not yet. They're still floating. And patoop, there you go. Okay, so now as you can see, my little punches are sinking. Okay, that's because we've removed the air from those little punches. Okay, that's exactly what you want to do. You want to see them sinking like that. Once they start sinking, you don't have to do it again. You may, as I said, have to do it 2, 3 times just to kind of get that air out. But now that we know they're sinking, there is no air in there. These are now heavier than the water. So what we're going to do is I'm going to take this and I'm going to pour our little spinach clips into our carbon solution. Now, I had the deeper one before. You have to make it in a little bit larger container so you have enough for your syringe to work. But we only want about 3 centimeters of that water in our other container. So I'm going to pull the back off of the syringe, okay? I'll do this so you can see. You don't want to squirt them out the tip because you'll damage those leaves. So you'll take the back off of the syringe and pour those little guys right into that beaker, okay? Now, as of right now, I made this little thing here. You don't need the napkin with the weird thing behind it, but I wanted you to be able to see our little leaves in there, okay? So, as you can see right now, these guys are all sunk to the bottom of our container, okay? So I'll make it to where you can see it here. They're all at the bottom of our container. Now, what we're going to do, I'm going to scooch this way just a little bit so we can see them a little better. Most of them are on this side. I'll turn it to where you can see them. There you go. All right. And so now we're watching these guys here. You can see them at the bottom. You don't see too much movement. There you go. There we go. There we go. Now I'm going to turn on my lights. Okay. Now remember when we talked about that photosynthesis, when we're watching this, okay, we're going to watch this very closely because what's happening is inside this little beaker here, the light is penetrating the water, okay? Now it won't penetrate too deep. That's why you want shallow water. But we're going to watch these little guys, and after a few moments, those guys are going to begin to float up. Now, as you're watching, I will just continue kind of chatting. But what we've got here is, just like we had our solar cell, now we have our plants, okay? Now, our plant is getting the photons from the sun, okay? And when it's getting we can actually already see the one guy moving a little bit there. As it's getting the photons from the sun, it is doing the same thing, and it is undergoing a chemical reaction, and that chemical reaction is kicking out oxygen, Okay, so you can actually watch these guys. I've got a couple that are beginning to move. I will turn this around a little bit, but we know our little photosynthesis the photons are going in, causing a chemical reaction that is kicking out the little oxygen. Now, before it kicks out the oxygen, our spinach actually fills up with oxygen. And so when it's filling up with oxygen, we'll watch this little guy right here. As it's filling up with oxygen, we can see that it is starting to kind of stand up, and it will eventually fill with enough oxygen to float to the surface. Okay. Now this one, it takes a couple minutes. It should be ready any second now. And so this one here, as it is filling up, well, I'm going to kind of twist it around so you guys can see a couple of the other ones too. But when they fill with oxygen, after they're filled with oxygen, they'll rise to the surface, and we know that they've got enough oxygen in there to actually start leaving oxygen, or oxygen to begin moving into the atmosphere. So I'm going to turn this just a little bit here and see if we can see some of these other guys and see if we're getting any movement off of those guys. These guys right here, we can actually see are already floating up to the surface. So we can see that these guys over here, as those little plants are standing up, and then they begin to move to the surface because they're now full of oxygen. So these little clippings, even though they're from the Walmart spinach here, these little clippings are already producing oxygen. You can see them as they're floating up from the bottom there. So yeah, they're no longer down here. We've got them up there. Eventually, they will have enough oxygen to make it all the way to the top. And then really after, it takes about 10 minutes and you'll have all of them in there up to the top. So we just want those couple that we see there that are now filled with oxygen because they've done that photosynthesis. These guys are now floating up to the top. So if you're doing this one at home, try it with different plants. Try it with different light sources. Oh yeah, see, look, they're just about there. This one here, like if you are doing it with students, the students will really get a kick out of this one because as it's sitting there, they'll be like, okay, they're not moving. And then just like these guys here, they'll begin to float. And that's because they're filling with oxygen from the chemical reaction that happens from light. And that chemical reaction is called photosynthesis. Okay? So it's the same as we did with that little circuit. We have the sun shooting the photons in and it respirating or breathing out oxygen. Okay? Now remember, you do need carbon for this because the plants actually take the carbon. Oh yeah, look at that. Whoop. Oh, there we go. Yeah, so we can see them really kind of getting some movement now. But the plants need that carbon to convert into oxygen. So we breathe out that carbon dioxide. These guys breathe in that carbon dioxide. And now we have quite a few of those little guys floating right on the top of our water. Okay? And that is the amazing process called photosynthesis. Thank you for watching. I hope you guys enjoyed this one. Try it at home. This is a really good one. My name is Mr. Dave, and this is the RayKitty Science Project. As I end everything, remember that science shows you matter.